Your notes define sample space as the set of all possible outcomes in a probability experiment. And the reason it's important to quantify, which means count, all the possible outcomes is because of the definition we looked at last week for probability. Probability is the ratio of favorable outcomes to possible outcomes. So you can't calculate what's probable until you first know what's possible. And using the breakfast example, the Lenny's example, if you had no knowledge of a person's preferences, like what they might choose for eggs or carbs, and you were just going to guess which breakfast combo they'd pick, you would have a 1/12 probability of guessing the breakfast, because there are 12 possible breakfast combinations, and you only get to guess at one of them. So one favorable outcome compared to 12 possible outcomes. The sample space, which we can get from the fundamental counting principle, or from a tree diagram, or sometimes a table, will tell us the total number of possible outcomes, and that's an important starting point for lots of probability calculations. If you flip a coin twice, there are 4 possible outcomes. We've looked at that sample space before. You could get heads heads, tails tails, or heads tails, tails heads. If you look at, if you imagine you were tossing a penny and then a nickel, you could get heads or tails on the penny, and then whether you got heads or tails on the penny, you could still get heads or tails on the nickel. And so here's a smaller version, a simpler example than the do now, but it also shows you a tree diagram, which when you follow the branches leads you to all the possible outcomes: heads heads, heads tails, tails heads, tails tails. There were 2 ways the penny could land, 2 ways the nickel could land. So 2 times 2 or 4 possible outcomes, fundamental counting principle. Sometimes the sample space is shown as a set of all possible outcomes, using set notation, which we've used before, braces, to show a set of elements.